Three-eyed Atlas is beating like a heart. Every 16 hours, the interstellar comet grows brighter, then dims again, a rhythmic pulse that scientists are only now beginning to understand, and the explanation is more spectacular than anyone imagined. In early December, scientists published a groundbreaking study. Over months of observation, they discovered a pattern in Three-Eye Atlas that no one had seen before. The comet systematically brightens and dims in a precise 16.16-hour rhythm. Imagine this, an object that has traveled billions of years through the void between stars is now pulsing before our eyes like a cosmic heart. The brightness changes are measurable, reproducible, and they tell a story about the true nature of this visitor. This isn't just a curiosity. This heartbeat is our window into understanding how comets from other star systems behave when they encounter our sun. Every pulse, every brightening, every dimming gives us data about processes happening on a surface that formed around a star we'll never see. The discovery came from careful photometric observations. Measuring the comet's brightness over time, astronomers noticed the pattern wasn't random. It was periodic, consistent, predictable. A research team published their findings in the journal Astronomy and Astrophysics, describing what they called a heartbeat pattern in the light curve. The internet, of course, immediately jumped to alien technology. Some speculated about thrusters, about artificial signals, about probes from distant civilizations, but the scientific explanation is far more elegant and far more telling about the nature of our universe. The explanation is as elegant as it is dramatic. Three-Eye Atlas is rotating like a slowly spinning top in space, but it's not a perfect sphere. On its surface are active regions, areas where frozen ice is exposed to the vacuum of space. Here's where it gets interesting. As Three-Eye Atlas approached the sun, solar radiation heated these ice regions. The ice sublimates, transforms directly from solid to gas without becoming liquid. This process generates powerful jets, fountains of gas and dust that shoot into space at thousands of miles per hour. But these jets don't fire constantly. They follow the comet's rotation. When a particularly active ice region faces the sun, a large jet explodes. The comet wraps itself in a brighter cloud of gas and dust. Its coma lights up. The brightness we see from Earth increases. 16 hours later, the same region rotates back toward the sun and the cycle repeats. That's the heartbeat. The comet is literally breathing, in rhythm with its own rotation, powered by the force of our sun hitting ice that froze in a different star system. Think about what this means. The ice on Three-Eye Atlas froze perhaps billions of years ago, orbiting a star we cannot identify, in a planetary system we'll never see. That ice traveled through the cold of interstellar space, where temperatures hover just above absolute zero. And now, for the first time in its existence, it's feeling the warmth of a star again, our star. And it's responding, it's erupting, it's creating this cosmic pulse that we can measure from 170 million miles away. The heartbeat wasn't the only surprise. A second study, published on December 1st, revealed something even more spectacular: cryovolcanoes, ice volcanoes. The images show spiral-shaped jets winding from Three-Eye Atlas's surface like cosmic tornadoes. These aren't simply gas eruptions. Scientists interpret them as a form of cryovolcanism, a phenomenon we otherwise only know from objects in the outer solar system, the moons of Saturn and Neptune, and the trans-Neptunian objects beyond Pluto. The term cryovolcanism refers to volcanic activity involving volatile substances like water, methane, or ammonia instead of molten rock. On Earth, volcanoes spew lava. On Three-Eye Atlas, they spew ice and gas. The mechanics are different, but the principle is the same: internal pressure finding release through surface eruptions. What makes this remarkable is the pattern. The jets aren't random. They're organized, spiraling, following the magnetic and rotational dynamics of the comet itself. Some researchers have compared them to the polar jets we see on Jupiter, enormous streams of material following magnetic field lines. What's fascinating, Three-Eye Atlas comes from a completely different star system, but its composition is strikingly similar to our own icy worlds. Abundant carbon dioxide, water ice, carbon monoxide, even nickel-bearing compounds, all substances we also find in our solar system. Spectroscopic analysis has been crucial here. By studying the light passing through Three-Eye Atlas's coma, scientists can identify which molecules are present. The signature of carbon dioxide is particularly strong, water ice as expected, but also more complex organic molecules, the building blocks of chemistry that could lead to life. The implication? Planetary systems might be universally similar in construction. The building blocks of life, the chemical processes, they might follow the same rules everywhere in the universe. This is profound. It suggests that the formation of our solar system wasn't unique. The processes that created Earth, that created the icy moons of Jupiter and Saturn, that created the Kuiper Belt objects beyond Neptune, Those same processes are happening around other stars. 3i Atlas is proof of concept. It's a sample from another laboratory, and the results are remarkably similar to our own. Some ask, why should we care about a pulsing ice ball? The answer lies in the uniqueness of this opportunity. 3i Atlas is only the third confirmed interstellar visitor we've ever seen. Oumuamua raced by too quickly in 2017, we barely had time for observations. Its elongated shape sparked endless speculation, but we never got close enough for detailed study. 2i Borisov in 2019 gave us more data, but its composition was less surprising. It looked like a fairly typical comet, just from elsewhere. 3i Loss is different. It came from the direction of Sagittarius, from the heart of our galaxy. It's given us months of observation time. Hubble, James Webb, Psyche, Mars orbiters, even Perseverance on Mars have photographed it. NASA coordinated a massive multi-mission observation campaign. The Hubble Space Telescope captured detailed images of the coma. The James Webb Space Telescope analyzed its infrared signature. NASA's Psyche mission, on its way to the asteroid belt, turned its instruments toward 3i Atlas and helped refine its trajectory. Mars orbiters watched it pass near the red planet. Even Perseverance on the Martian surface attempted observations. This level of coordination is unprecedented. Never before have we marshaled so many resources to study a single interstellar object, and never before have we had this much time. 3i Atlas has been visible since July, giving us 5 full months of data collection. And now, in its final weeks in our solar system, it's showing us its heartbeat. It's showing us its ice volcanoes. It's giving us a glimpse into processes occurring in other star systems, processes that might also be forming worlds there that could harbor life. On December 19th, in exactly 2 weeks, 3i Atlas will reach its closest point to Earth, 170 million miles. That sounds far, but on the cosmic scale, it's a blink of an eye. It's closer than Mars is at its most distant point from us. For amateur astronomers with larger telescopes, this is the last chance. The comet is visible in the constellation Leo in the morning twilight near the bright star Regulus. Magnitude 10 to 11, faint, but reachable under dark skies with a telescope of at least 8 inches in diameter. You won't see the heartbeat with your eyes. The 16-hour cycle is too slow, the brightness changes too subtle. But knowing it's there, knowing that as you watch, ice volcanoes are erupting on a surface that came from another star, that adds something profound to the observation. After December 19th, it accelerates, its velocity increases. The sun's gravity, which has been slowing it slightly during its inbound journey, now works in reverse. Like a slingshot, the sun flings 3i Atlas back toward interstellar space. And sometime in 2026, it will cross the boundary where the sun's influence ends, and it will be gone, traveling at the same speed it arrived, 153,000 miles per hour. The heartbeat of 3i Atlas teaches us something fundamental. Space is not dead. Even an icy comet that has drifted through the void for billions of years awakens to life when it feels sunlight. These jets, these ice volcanoes, this pulsing rhythm, they all speak of a universe that is dynamic, active, full of surprising processes, and they remind us why we look to the skies. There's a philosophical dimension here worth considering. For billions of years, 3i Atlas was dormant. No sunlight reached it, no jets erupted. It was, for all intents and purposes, dead matter drifting through darkness. But dormant is not the same as dead. The potential was always there, locked in the ice, waiting for energy. And when that energy came, when our sun's light finally reached it, it exploded into activity. In a sense, our sun gave it life, however briefly. In a few months, when it returns to the cold, it will go dormant again. But the potential remains. Perhaps millions of years from now, another sun will wake it. Another heartbeat will begin. Every generation has its own cosmic visitors. In the 1970s, it was Kohatek. In the 1990s, Hale-Bopp. But interstellar comets? They're something special. They're messengers from other worlds, worlds we'll never visit, but whose history they carry with them. Those of you who remember Hale-Bopp in 1997 will recall how it dominated the sky for months. It was visible to the naked eye, a spectacular sight with its dual tails stretching across the heavens. 3i Atlas is nothing like that, it's far too faint. But what it lacks in brightness, it makes up for in significance. Hale-Bopp was a neighbor, from our own solar system. 3i Atlas is a stranger, from unimaginably far away, carrying information we cannot get any other way. 3i Atlas will be at its closest in 2 weeks. Its heartbeat will continue pulsing finest 16 hours again and again as it moves away from us. In a few months, it will be too faint to observe. In a few years, it will reach interstellar cold again. Its jets will fall silent. Its heartbeat will stop. But it will keep traveling, perhaps for millions of years, perhaps until it reaches another star system where other eyes or telescopes will measure its next heartbeat. Perhaps some future civilization on a world orbiting a star we haven't even cataloged will watch 3I Atlas light up as it feels their sun's warmth. And perhaps they'll wonder, as we do, about the worlds it visited before. Perhaps they'll detect traces of our sun's influence, solar wind particles embedded in the ice, isotopic signatures that mark it as a visitor to our particular corner of the galaxy. That's the beauty of interstellar visitors. They come, they teach us, and they travel on. 3I Atlas's lesson? Even in the endless darkness of space, a heart beats, if only for a brief cosmic moment. If you want to learn more about 3I Atlas or about the other interstellar visitors we've seen, I've put links in the description. And if you find this cosmic heartbeat as fascinating as I do, let me know in the comments.